If you don't like panic but still want answers, you've come to the right place. We're about to explore a scenario that feels like science fiction, but understanding it reveals just how deeply connected we are to the star at the center of our solar system. So, listen quick. The sun goes boom. What actually happens next? Now, to be clear, our sun isn't the type of star that will explode in a dramatic supernova. That fiery end is reserved for stars much more massive than our own. In about 5 billion years, it will swell into a red giant, a process that will be gradual, and for humanity, just as final. But for our thought experiment, let's imagine the impossible. A sudden cataclysmic explosion happens tomorrow. The sun, our source of light, warmth, and life, simply vanishes in a final, brilliant burst of energy. What would that mean for us, here on Earth, 150 million kilometers away? Here's the short version, and it starts with a strange, silent countdown. Light from the blast and the subsequent darkness reaches us in 8 minutes and 20 seconds. The same goes for its gravitational pull. For that brief window, we are living in the past, orbiting and basking in the light of a star that no longer exists. For 8 minutes and 20 seconds, everything outside will seem completely normal. People will finish their morning coffee, children will play in schoolyards, the tides will ebb and flow as they always have. No one on Earth would have any idea that the single most important object in our sky is already gone. We would be blissfully unaware, living on borrowed time, ghosts of sunlight still warming our faces. It's a chilling thought. The ultimate catastrophe has already occurred, but the news, traveling at the fastest speed possible in the universe, has yet to arrive. After that, the sunlight and heat vanish instantly. It wouldn't be like a sunset. One moment the world is bathed in light, the next, it's plunged into a darkness deeper than any night. The moon, which only shines by reflecting sunlight, would disappear. The only light left in the sky would be the distant cold twinkle of the stars. Simultaneously, the initial wave of high-energy radiation from the explosion would wash over the planet. Anyone on the sun-facing side of Earth would be exposed to a lethal dose of radiation. It would be a silent, invisible, and instantaneous threat. With the sun's warmth gone, temperatures start dropping fast across the entire planet. The global average temperature, normally around 15 degrees Celsius, would fall to freezing within a week. Within a year, it would plummet to a devastating -73 degrees Celsius. This isn't a gentle slide into an ice age, it's a catastrophic, planet-wide flash freeze. Weather as we know it collapses. The sun is the engine of our climate, driving winds, ocean currents, and the water cycle. Without it, that engine seizes. The great storms and jet streams would spin down. The air would become eerily still. The final act of our atmosphere would be a single, planet-wide snowfall, as all remaining moisture in the air freezes and falls to the ground, blanketing the world in a permanent layer of ice and snow. Power grids fail within days. Solar panels would be useless instantly. Hydroelectric dams would freeze. Wind turbines would fall silent in the still air. Fossil fuel plants would run only as long as their fuel reserves lasted, but with global transportation frozen, those reserves would be finite. For a few days or weeks, pockets of civilization might have power, but a worldwide blackout is inevitable. The lights of humanity would blink out, one by one. The oceans begin freezing. This process would be slower. The sheer volume of water in our oceans acts as a massive heat reservoir. It would take months, perhaps even a year, for a significant layer of ice to form on the surface. Over decades and centuries, this ice sheet would thicken, potentially becoming kilometers deep. However, the oceans wouldn't freeze solid. Geothermal vents on the ocean floor would continue to pump heat and chemicals into the deep, creating a potential, albeit slim, sanctuary for microbial life. A final echo of the vibrant ecosystems that once thrived. Breathable air becomes scarce over the long term. While the atmosphere wouldn't vanish instantly, the extreme cold would cause parts of it to liquefy, or even freeze, falling to the surface like nitrogen snow. Over a very long period, the air we depend on would be gone. But the more immediate problem is photosynthesis. Without sunlight, nearly all plant life on the planet would die within weeks. This would not only destroy the foundation of almost every food chain but also halt the process that replenishes the oxygen in our atmosphere. Humanity wouldn't survive unprotected. The surface of the Earth would become an uninhabitable, frozen desert, bombarded by cosmic radiation without the sun's magnetic field to protect us. And what of Earth itself? The moment the sun's gravity vanished, our planet would cease its orbit. It would become a rogue planet, flying off in a straight line into the cold, dark void of interstellar space, a frozen tomb carrying the memory of a world teeming with life. So, could we survive? For the first days, it's about emergency shelters. The only hope for long-term survival would be to go deep underground. We would need to build self-sustaining habitats, likely powered by geothermal energy, tapping into the planet's own internal heat, or nuclear power. These bunkers would have to be technological arks complete with advanced life support, hydroponic farms for food, and water recycling systems. It would be a monumental feat of engineering and willpower undertaken in the face of unimaginable loss. Dwindling resources would force rationing and painful trade-offs almost immediately. Every calorie, every drop of water, every watt of electricity would become precious. The psychological toll would be immense. Humanity would be living in a confined, artificial world, knowing that the vibrant, sunlit planet they once knew is gone forever. The sky, the seasons, the very concept of a day, all would be relics of a lost era. Tough choices would determine who gets help and supplies. The brutal reality is that not everyone could be saved. Access to the deep, geothermal-powered shelters would be incredibly limited. Who gets a spot? Scientists, engineers, leaders, families. These are impossible questions, and the answers would shape the future of what remains of our species. It would be a story of survival, but also one of profound inequality and loss. It's a scary scenario, but it's also a powerful reminder. Our star's steady, predictable glow is everything. It's easy to take for granted. We complain when it's too hot or hidden by clouds, but its constant presence is the silent, unacknowledged foundation of our entire world. It dictates our days, powers our planet, and holds us in a gentle gravitational embrace. Thinking about its absence isn't about dwelling on doom, it's about appreciating the profound, delicate balance that makes our existence possible. The light that will reach Earth 8 minutes from now is a gift, a daily miracle that we are incredibly fortunate to receive.